In this lesson, we are going to talk about the term coterminal and also related angles. Later on in this section, you are going to see trig equations that you have to solve to find the angle. Now, one thing you have to remember is that when you had linear equations, something like x plus 2 is equal to 5, then if you solve this equation, you could get only one unique answer, and there is no multiple answers here. For instance, here you would say I move 2 to the right, I get x is 5 minus 2 is equal to 3. Or when you were solving quadratic equations, something like x squared minus 1 is equal to 0, you would get at most two answers. You can get 0, 1, or 2. But when you are trying to solve trig equations, by the nature of the functions, there is infinite number of solutions depending on the domain of the problem. Later on, you will see that trig equations, trig functions, they have very interesting graphs. For instance, sine function, give you one example, looks like a function like this one, which goes from negative infinity to plus infinity. Now, if we decide that our domain is from here, from this point to this point, then you can see that the solution to this is going to be all the x-intercepts, which are going to be here, here, here. All these points are going to be the solution to our trig equation. In this lesson, we are going to try to see how we can find all the possible solutions based on our domain here. The first example is that sine A is 3 over 5, and we know angle A lies in the first quadrant. We are supposed to find the exact values for cos A and tan A. First of all, we are going to draw our unit circle. We know that angle A is in first quadrant, which is here. So if this is angle A, then we know that sine A is 3 over 5. To find the other ones, meaning cos A and tan A, we need to find the radius of the circle. By definition, sine A is equal to y over r, which is 3 over 5. This automatically tells us that y is equal to 3, r is equal to 5. But by definition, r squared is x squared plus y squared. Remember, this point had the coordinate xy and r is here. Then by using Pythagorean theorem, this is x, this is y, x squared plus y squared is r squared, or from here I get y, r squared is 5 squared, which is 25, is x squared plus y squared. 3 squared is 9. If I move this to the left, I get x squared is 25 minus 9, which is 16. So x is plus or minus 4. But since we know that angle A lies in the first quadrant, this means that x has to be positive. So negative is not acceptable, so we say that x is 4. Now, since we know x, we can say that cos A, which is x over r, is equal to 4 over r is 5, and tan A is y over x, which is going to be y is 3 over x, which is 4. So this way we could find, sine, cos, and tan of angle A by knowing the location of angle, which is in the first quadrant. The next part of the question says, determine the primary trig ratios for another angle between 0 and 360 that has the same sine value. Again, if you recall that our sine was 3/5. This was the value given. Again, our unit circle looks like this one. This is our angle A. Now, we know that sine is positive, and sine is defined as y/r. Y is here. The other quadrant that y is positive is the second quadrant. This means that if I reflect this point on the y-axis, I get this point. So this means that this angle from here to here also has a sine which is positive and is equal to 3/5. But to find that value, remember that this point was x and y, and we found that x is 4 and y is 3. The reflection here is going to have a negative value for x, so it becomes -4, but the y stays the same as 3. So the sine of this angle is going to be, r is going to stay at 5, which is x squared plus y squared, which is -4 squared plus 3 squared, which is square root of 25, which is 5. So the sine of this angle, the new one, is going to be the same as 3/5, but cos, let's call it angle B, is going to be x/r, but x in this case for this point is going to be -4/5, and tan B is going to be y/x, which is going to be 3/4. So this is our second angle, which is going to have the same sine, but two different values for cos and tan. The next part says, draw a diagram showing the locations of the two angles. How are the two angles related? You can see as we drawn the angles before here, angle A is here and angle B is this one. Now remember, if this is angle A, this one is also angle A. This means that angle A and B are going to have a sum equal to 180 degrees. Or this means that the angle A and B are complementary of each other. The sum is equal to 180. Now the last part says, use a calculator to help you find the two angles. We know that sine A is 3/5. If we use the inverse function on the calculator, we get that A is approximately 37 degrees. And angle B, we said, is 180 minus angle A, which is 180 minus 37, which is going to be about 143 degrees. In the next example, we are supposed to determine another angle between 0 and 360 that has the same cosine as angle A in the previous example. And then also, what is the relationship between this angle and angle A? If you recall, the cosine of the angle was 4/5. Now again, this is our unit circle. We know that this angle, the cos, by definition is x/r. And we also know that y is equal to 3 from previous problem, and x is equal to 4. So this means that this point is 4 and 3. Now, we know that cos is positive, and cos is x/r. the only possible angle is going to be in quadrant 4 because x is positive here. So if I find the reflection of this point on here, then the other angle is going to be this angle. Now, for this point, let's call this one, let's call it A prime. We see that it's going to have the same x value, which is going to be 4, but the y value is going to be negative, which is going to be negative 3. So this means that the other point is 4 and negative 3. Now to find the angle is very simple. We know that we found the angle to be 37 degrees. A was 37 from previous problem. Now this angle here is going to be 360 minus 37, which is going to be 323 degrees. Now the question is, what is the relationship between angle A and this new angle which I drew here? Is that the sum of the angles is 360 degrees. 37 and 323 is going to give you the sum equal to 360. Now the next part of the question says determine another angle between 0 and 360 that has the same tangent as angle A in example 1, and then what is the relationship between these two angles. Again, if you remember from previous problem, the tangent of angle A was 3/4. If we draw again the unit circle, by definition, tan A is y over x. So this means that if this is point A, our x is 4, again our y is 3. Now the tangent is positive 3/4, and it's in the first quadrant. The only place that we can have x and y the same sign is quadrant 3 here, because x is negative, y is negative. Division of two negative numbers gives you positive. So this means that I have to find the reflection of point A at the origin, so I get a point like here, A prime. Now A prime is going to have the coordinate -4 and -3 now. The angle that we have to find is this angle here. This is the angle we have to find. We know that this angle is going to be 37 degrees. So our new angle is going to be 180 plus 37, which is 217, which is this angle here. This is our new angle here. Now the question is that what is the relationship between this new angle and our original 37 degrees angle? The relationship is going to be the difference between these two angles is 180 degrees, because 217 minus 37 is going to give you 180 degrees. In the next example, we know that the city hall is at the origin of the Cartesian coordinate system. So if this is the Cartesian coordinate system, x and y, we know the city hall is here. And we know Ted's house is at the point -6 and 2.5. So it's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 2.5. So it's going to be somewhere around here. This is Ted's house. The angle of rotation for Suzette's house has the same tangent ratio as the angle of rotation for Ted's house. Where is Suzette's house? In the second quadrant, we know that the y value is positive, x is negative. So your tangent is negative. Now, the other quadrant that tangent is negative is going to be in quadrant 4. Because in quadrant 4, x is positive, y is negative. So this means that if I find the reflection of this point here, this is going to be Suzette's house. Remember that Ted's house was we had the coordinate negative 6 and 2.5. In the fourth quadrant, we know that if I find a reflection, I'm going to change the x to a positive value, so it's going to be 6, and the y is going to be negative value, so it's going to be negative 2.5. So this is going to be the coordinate of Suzette's house. Now the next question says, find the angles in standard position if the lines drawn from the city hall to each of the two houses are terminal arms. To find the angles in standard position, we are going to reflect this point to find the reference angle. So I'm going to reflect this one on the y-axis, so I'm going to get a point which is 6 and 2.5, because now your x value is going to be positive. So this is going to be my reference angle. So I have to find the angle. We know that x is 6 and y is 2.5. So I'm going to write that tan theta by definition is y over x, which is 2.5 over 6. If we use the inverse function, we get theta is going to be approximately 23 degrees. So this angle is 23 degrees. Now I have to find this angle. You can easily see that this angle is going to be 180 minus 23, which is 157 degrees. To find this angle, if I find the reflection of this point on the x-axis, I'm going to get the same point here. So we know this angle is 23 degrees. So the other angle is going to be 360 minus 23, which is going to give me 337 degrees. Now we are going to define a new topic here called the coterminal. The coterminal angles are angles that they have their terminal arm to be on top of each other. For instance, consider an angle of 30 degrees as shown here. The initial arm of angle 30 is the positive x-axis. Now let's assume that we take the terminal arm and we rotate it 360. Then we're going to end up at 390, because we go 30 degrees plus 360 is 390, and we end up in this position, which is exactly on top of the terminal arm of angle 30 degrees. This means that angle 30 and 390, we call them coterminal. If I do this one another rotation, then I'm going to get 390 plus 360, which is 750, which I'm going to get this case. If I continue rotating it another time, I'm going to get this possibility. Now, rotation can be counterclockwise, which is going to be 360. You add 360 every time to your original angle. Or you can go counterclockwise, which is negative 360. So you're going to add negative 360 every time. This means that first you start with 360, then you're going to add negative 360 plus 30, which is negative 330. Then you're going to add another negative 360 to it, so you're going to get negative 360, negative 330, which is going to be negative 690, and so forth. In general, if you have an angle theta, you can either go plus or minus 360 times n, where n can be equal to 1, 2, 3, and so forth. The plus 1 is when you go counterclockwise, and minus 360 is going to be when you go clockwise direction. These angles are called coterminal when they have the same terminal arm. The next question says find three other positive angles that have the same terminal arm as 30 degrees. So we start with 30 because we want positive angles, so we are going to go counterclockwise. The first one, remember, this one is plus or minus 360 times n. But since we want positive, forget about going clockwise. So we have to solve 3 plus 360n. Let's say n is 1. So we get 30 plus 360 times 1, which is 390. If n is 2, we get 30 plus 360 times 2, which is going to be 750. If n is 3, then we get 30 plus 360 times 3, which is 1110. The next example says now find three negative angles. Again, we have the case of 30 plus or minus 360 times n. Since we're talking about negative, so the plus is gone. So we get 30 minus 360n. If n is equal to 1, we get 30 minus 360 times 1, which is going to give you negative 330. If n is 2, we get 30 minus 360 times 2, which is negative 690. And if n is 3, we get 30 minus 360 times 3, which is negative 1050. So these are three negative angles that are coterminal to 30 degrees. Now we are going to talk about what we call the cast rule. Consider your Cartesian coordinate system as is shown here. This is your x and this is your y. We know that in quadrant 1, we know that cos, sine, and tan are all positive. Let's call this one A. A means all, so all are positive. Then we go to quadrant 2. You remember that quadrant 2, we are going to have sine positive because by definition sine is equal to y over r, and y here is positive. But cos and tan are negative. Since sine is the only one which is positive, let's denote the second quadrant with S. Now we go to third quadrant here. In third quadrant, we know that tan theta is y over x. Since x and y are both negative here, so tan is positive. Since the only trig ratio which is positive is tan, let's denote this one to be t. And last one, quadrant 4. We know that cos by definition is x over r. And x here is positive. So, and also sine and tan are going to be negative. Since the only positive ratio is cos, let's denote this one to be c. Now, if we go in this direction, we get CAST, which is cast. So that's one way of memorizing quadrants that the trig ratios are positive. So draw your Cartesian coordinate system and start putting the first letter, the letters of the word cast, starting from quadrant 4. So you know that cos is positive here, all of them are positive here, sine is positive here, and tan is positive here.